Questions. By what mechanism might an animal come to learn that a prey species will appear at a certain time of day in a certain location? So that would be periodic timing linked to the circadian rhythm in a 24-hour cycle. Describe the peak procedure for interval timing, including likely results for intervals of 20 seconds versus 40 seconds. Okay, so basically people respond around the mean of 20 seconds or the mean of 40 seconds, and it's like a normal curve around that mean in both cases. But because 40 seconds is a longer interval than 20 seconds, the variability in the responses, there is more variability in the responses, so the normal curve is wider. Describe evidence for the claim that rats can process number and short time intervals simultaneously. Okay, so they did an experiment in which they varied both number and the timing of pulses, and the rats were able to choose like what 2 was, when 2 was the timing of the pulses or 2 was the number of the pulses. Which discrimination would be easier for human infants to make, 8 versus 16 dots or 16 versus 24 dots? Why? 8 versus 16 dots would be easier because it's on a 1-to-2 ratio, and 16 versus 24 dots is on a 2-to-3 ratio, which does not work well for brains. What brain areas are likely involved in the processing of magnitude, including timing and number? The intraparietal sulcus, in the parietal cortex, and the pineal gland. What are the signature properties of the approximate number system and the object tracking system? Okay, so the object tracking system works up for like 4 objects. You can watch objects move in and out of your field of vision, and the way you like encode these are basically like object, 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 and object. That's it. So those are for small numbers, basically how it works. And the approximate number system, that's more like when you click a key a bunch of times and you're prevented from counting it by saying like the every time you count instead. In an experiment, you still kind of know how many times you press the button. And it is also under the dictates of Weber's law, which is the ratio, and the just noticeable difference, like we need a ratio between amounts or magnitudes to be large enough for us to discern it, or we don't. How might the approximate number system and the object tracking system each solve a simple addition problem, e.g. 1 plus 2? Okay, so the object tracking system would see like the 3 objects, and it would be like object, object, object. So if you showed it 3 objects, it would be happy with this. But if you showed it only object, object, it would understand something is wrong with this. So the approximate number system, how would it solve 1 plus 2? I mean, it just doesn't, because it only works for larger numbers than that. But I guess fundamentally it would understand that 1 plus 2, it would be like more than 1 and more than 2. What similarities and differences exist between humans and other animals in relation to numerical cognition? So the big difference is like humans use language to mediate more precision in doing operations on larger numbers. So humans also use the object tracking system for small number of objects, it sounds like, and we also use the approximate number system when we're not counting things. So I think that's the big difference.